Hi, my name is Shadi Atia, professor at Liège University in Belgium, and today's presentation is about planning and controlling your experiment within a playlist on experimental research. Well, experiments are at the core of laboratory research. Therefore, the audience of this presentation is mainly postgraduate scientists and scientists who are conducting or seek to conduct research in the field of social sciences, life sciences, medical sciences, and natural sciences. And for sure, the presentation audience is also mentors and supervisors. When we talk about research methods, there are four main research methods grouped under two categories. Category one is quantitative research that includes the modeling research, observational research, and experimental research. And the second group is the qualitative research. In this sense, we are focusing on experimental research method, and some other people can combine different types, and they call it the mixed approach that combines one of the quantitative research methods with qualitative research methods. But before proceeding, if somebody asks me what's the main difference between experimental research and observational research, experimental research is manipulative, which means that the study design alters variables or one variable for comparison against a control condition or a baseline, while observational research is non-manipulative, so you do not intervene, and the study design that typically represents realistic conditions. Also, when I talk about experimental research, I'm talking here about controlled experimental research. So we seek eliminating or controlling other factors, and we have a controlled setting or a controlled environment, and therefore we call it experimental controlled research. If we are looking at other aspects for non-randomized selection or non-experimental control, then you have to follow the series on observational research. Now, today's objective is mainly to provide step-by-step guidance on how to define the research variables and how to define my research questions and your control for your trials. The content of the presentation of today is mainly the hypothesis, how to have introduction first about how to control and plan your research, what is a hypothesis, what is operationalization, what is the attribution problem, what is the pretest and the post-test for my experiment, and how to define a control group or control my experiment before finalizing with the takeaway message. Now let's start with the introduction, and let's discuss the first term that you need to learn about, which is the research design. The overall research design is the overall strategy that you choose to integrate the different components of the study in a coherent and logical way, thereby ensuring you will effectively address the research problem, and research design constitutes the blueprint for the collection, measurement, and analysis of data. So therefore, your research design needs to be well done. Experimental research design relies on two important factors. We call it the independent variables and the dependent variables. When we talk about independent variables, we mean that the researcher has to control over them. They are intentionally changed to see the effect of on the dependent variable. And dependent variables, they are what is measured or what changes in response to the independent variable. So it's very important when we define this relation that we have defined our independent variables and our dependent variables in order to be able to investigate a cause-effect relation. And we should not forget when we are conducting our research that experimental research requires 3 R's. We need to have a high level of randomization, we need to have a high level of replication, and we need to have a high level of reducing noise or controlling the experiment, including blindness, to make sure that we are following best practices and that we have confidence in the results. If you want to know more about those aspects, you can follow the videos on randomization and replication. But what is also very important when we plan our research, to avoid the confirmation bias. Well, there's different examples of confirmation bias, but the confirmation bias, before talking about them, is the tendency for experimenters to give their expected outcome too much weight when measuring results, leading to inaccurate findings. And we see that in different forms. For example, by not seeking out objective facts, or by interpreting information to support your existing belief, or only remembering details that uphold your belief, or ignoring information that challenges your belief. So it's very important to avoid the confirmation bias, and there is techniques for that, and one of them is the confidence level. We calculate the confidence level, or we call it technically the confidence interval. It is simply the degree of uncertainty around a certain effect And in this sense, we are tackling the sample size, the sampling errors, the sample variations, and we can have different levels of confidence in our test. And if the experiment were to be repeated a large number of times, each time by randomly sampling the same number of individuals or subjects from the population or from the sample pool, you can define this confidence. So how much did the outlier affect the confidence interval? This will be the answer that will allow us to define the confidence interval for our sample. What is very also important to take into account when we talk about planning and controlling our experiment, the comparative nature of experimental research. Usually an experimental research compare variations of an experiment, and researchers in many cases fail in this process to measure against a benchmark. So the benchmark concept is very important. Therefore, a statistically significant portion of subjects in an experiment must be shielded from exposure to variables. And since there is a lot of room for error within scientific methods, failing to compare is vital for accurate analysis. So one common source of the error within experimentation is the confirmation bias, as we mentioned. So therefore, it's very important to be aware about these things. Now let's talk about the hypothesis, which will be a crucial construct that around it the whole experiment will be designed and planned. And in this sense, when we talk about hypotheses, we need to be very aware about what are my study variables. During my operationalization process, I need to define my study variables once I'm done with my literature review and conceptualization of theoretical framework. So simply, experimental research contains dependent and independent and control variables. So we are talking here about three types of variables: independent, dependent, and controlled variables. The control variables, they can be called extraneous variables, so they are from outside. They are called extraneous or control. We need to look at them. And the dependent variable are the variables being treated or manipulated and are sometimes called the subject of the research. The independent variable are the experimental treatment being exerted on the dependent variable. And it's very important to define those three parameters. Now, when we talk about extraneous variables or the control variables, they are in experimental research contains dependent and control that we talked about, but a control variable is any variable that you are not investigated that can potentially affect the dependent variable of your research study, and therefore we are interested in controlling those variables. Confounding variables are similar to the control variables, the difference being that they are affecting two variables that are not sparsely related. So I can have a cause-effect relation, I have an independent variable, I have a dependent variable, and here I can have other factors that we can call confounding variables. In any case, if you have confounding variables or control variables, we try our best to neutralize them. Very important to look at that. And keep into account that when I'm talking about the control variable, I must invest in defining it. Because many researchers, when they conduct experimental research, they only describe their independent variable, let's say coffee drinking influence on heart disease, which is the dependent variable, without mentioning what are the control variables. Did you fix the gender, the age, the ethnicity, and so on. These are just examples. So the control variables need to be controlled for accurate experiments and eliminate external factors. And the greater the control of your control variable, the more certain we can be. So don't talk with me about experimental research without describing your control variables. If you only talk about independent and dependent variables, then your study is not complete. So in this sense, when we develop our hypothesis, a hypothesis is simply a statement intended to be tested empirically, and it proposes how a set of variables are related. It can be complex depending on the scope conditions, and the scope conditions are determining the situations in which a theory claim it can describe what happens. So it's very important to build on that, and all theories have limited scope that must be kept in mind when conducting an experiment. So it's very important that there will be always limitation for my theory, and if I'm conducting the experiment to test this theory, I have to be very vigilant, and I have to be very objective, and I have to test my 3 R's, and I have to define the independent, dependent, and the control variables. Following up on hypotheses, there's different types of hypotheses. We have the null hypothesis, which is that the independent variables does not affect the dependent variable, or no difference on dependent between the conditions. So then we call it a null hypothesis. And we have experimental hypotheses, whereas there is a negative or a positive effect, and there will be a difference or a variance when we are measuring the statistical variance between the conditions. And then in this sense, this variance can be directional, unidirectional, non-directional, or bidirectional. So it's very important to look at that, and don't think that a null hypothesis is not a result. A null hypothesis is a result, and it must be reported, and it must be published. So don't worry about that, and you should not force only your research to focus on the experimental hypothesis if it's positive or negative. It's also part of research and part of the game. There is today more awareness to accept the null hypothesis. So this is the basic when we talk about preparation and controlling. Let's go now into operationalization. Just to give you a reminder, what is operationalization? It's a step of research design that cannot be missed. It allows to find procedures to measure and manipulate your variables. So you have to learn about previous protocols, previous standards, what are the best practices to measure this variable, and it translates abstract concept into more concrete variables. So your concept or your ideas that you were exploring in your literature review, or that you are worried about in your overall investigation, you will translate these concepts and these ideas into variables that have sub-variables and that they have instruments and they can be measured with specific empirical measuring approach. So operationalization is a translation work. It translates abstract concept and theoretical aspect into concrete variables that can be measured, and the concept must be captured in as much as a direct way as possible. Now this is an overall of a process of operationalization. If anybody is starting his or her research, you start with your problem statement, you set your aims and goals, you have a broad research question, then you conduct your literature review. From the literature review, you try to develop a basic or an initial theoretical framework with concepts and main ideas and variables. Then you start to investigate the potential for relationship between certain variables, and you develop a relations framework, and this is still before starting. And once you have a hunch or a feeling that you are want to check or you want to investigate a certain correlation or a certain potential correlation, you can start the operationalization process, where you will narrow down your research question, you will be more specific with your selection of your variables, and then you start the data collection process. So in fact, you start when you do your operationalization with the literature review stage, which will help you to define the concepts, and then you can go define the domain of your concept, and you can also conduct expert interviews in the beginning to define your concepts or to define your variables that you want to investigate. Take care that operationalization is not only that you are sitting doing desk work, reading and defining your concept. Sometimes you can be very effective and very efficient if you plan 1 or 2 interviews with experts to help you to define the variables of your studies that are still unknown, or that there's high uncertainty about them, and that you wish to further investigate their influence or their effect within an experimental setting. So this is very important, because you have to define your domain and concepts through literature, but also why not benefiting from experts. So it helps you to find the indicators for each of the concepts that you are interested, and it will help you to prepare your relations framework or theoretical framework. And the relation framework is a translation in form of graphics of the key elements of the research study as key concepts and theories, and then you can translate it easily into variables, and then you can define your independent and your dependent variables. And it's very important in this sense also to define your cause-effect potential relation that you are looking to investigate. So this is very important. But never forget this question when somebody present their research plan for experimental research. First thing I ask about, what is your variables, what are your sub-variables, and what are your indicators. Variables are simply the researcher has control over them. They are intentionally changed to see the effect on the dependent variable. Sub-variables, they are what is measured or what changes in response to the independent variable. And indicators, they are what is measured or what changes in response to the independent variables. So it's very important to keep those definitions into account and have them already in your relationships framework or in your theoretical framework. As part of your presentation, as part of your preparation for experimental research, like we said before, you have conducted your literature review to provide knowledge on the topic of your concept of your research, determine the key concept and your ideas, and you can start to investigate your hypothesis. Then you define the domain of concepts and you narrow down your work a bit. You can go more in concrete by determining what variables can be measured, because not every variable I'm interested to investigate can be measurable. Maybe the setting, the experimental setting cannot allow it. Maybe it's difficult, maybe it's tedious, maybe it requires a lot of permissions. So this is very important. Here comes the feasibility when you define the variables and you determine how each variable can be measured is very important. And finally, you make your selection in order to start your work. So this is the important part when it comes to operationalization. Let's talk about the attribution problem now. Well, most of the cases we are talking here about research-driven design, so it's very important. So the attribution problem solution is important. In the design, all factors need to be controlled, and solution to that is to isolate the treatment effect and other factor effects. And you must make sure that you have invested enough time in this control aspect. So it's not only the independent and the dependent variable, but also I have to control the extraneous or the co-founding variables. So the attribution problem is the comparison between before treatment and after treatment. Because if I do not have this approach of comparison, then I will not be able to benchmark, or I will not be able to communicate or document any difference or any variance. So it's very important to take this into account. So comparisons need to be between factual with treatment situations and counterfactual situation without treatment situations. So this is a fundamental principle when we plan our experiment, before and after. And simulation needed to be done for the counterfactual simulation, and we must have a control group. So it's very important to have a control group, meaning that I have to divide my sample and I have a group that will have a placebo or will not be exposed to the intervention, depending on your subject. If it's human being, you must have as placebo. If they are subjects like material samples or objects, then you don't need to have a placebo, you just have a baseline reference to use it, but you must have a control group to start your comparison. So as part of your attribution problem, we do not know if observed differences between the pre-test and the post-test are due to the intervention, or if other factors are responsible of those changes. This is a big problem, because sometimes you assume that when you drink coffee, you will have less heart disease, for example, but in fact it was not the effect of coffee, it was the effect of the water, for example, or the effect of certain habits that you were associated with drinking coffee. You were taking a certain substance, and this substance had an influence. So it's very important that we make pre-test and post-test, and the question can the change be attributed to the treatment? Are we confident? Do we have a confidence enough that this change or this variable that we will later prove to have a correlation or maybe a causation, is it really related to this treatment or not? So this problem is called the attribution problem, and it's part of the control measures when we talked about the 3 R's: randomization, replication, and reduction of noise. So this is the the third R, which is reduction of noise or control. I have to ask myself if this problem or this intervention is really is the only or the sole influential parameter on the results. And this whole issue or this dilemma is called the attribution problem. So when you are asked about the attribution problem, you must have this section in your methodology, and you must describe it, and you must talk about it in your methodological chapter. This brings me to the logical step now about pre-test and post-test. So like I said before, there is a comparative nature in experimental research, so we need to have this approach of comparison. But when somebody asks me what is actually pre-test and post-test more into detail, actually it is a pre-test and a post-test is used to compare both alternatives, and the basic premise behind the pre-test post-test design involves obtaining a pretest measure of the outcome of interest prior to the administering some treatment, followed by a post-test on the same measure after treatment occurs. Very important. And this brings me to the baseline or the placebo concept. If we are talking with if our subjects are human beings, then we must have a placebo. If we are having objects, dummies, machines, prototypes, samples, materials, buildings, whatever structures, then we are talking about our baseline. I must define my baseline. So experiment commonly compare subjects, whatever they are, receiving a certain treatment or an intervention to receiving a placebo or a no treatment. And this must be included in your research design prior to conducting your experiments. So, as I mentioned before, subject can be varying, whether they are human, animals, plants, materials, structures, machines, devices, dummies, and so on. But in experiments, subjects assigned to an untreated baseline group are compared to a subject assigned to a treatment or an intervention group. This is crucial. And don't get confused. Again, if you are handling human beings, it's called a placebo. As you can see in this presentation, I want to test a new drug. I have my control group, which is the baseline, which is receiving a placebo, and I have my drug group that will receive the drug, and then I can start to run my different comparisons. I can see the impact and the outcome, and I can say I have to report what is the control group performance, the intervention 1, intervention 2, intervention 3, and based on that I can develop my research. So it's very important to keep in mind that when we conduct experimental research, we must have the control, reduction of noise aspect, and the attribution problem forces us to have a pre-test and a post-test, and to have a baseline or a placebo versus the treatment group. And this is very important to distinguish both. We do test before and after, and we do test for people with treatment and without treatment, also before and after. And this brings me to the control group, which is one of the final concepts in today's presentation. What is a control group and why do you use them? Well, what is a control group? Simply, a control group is used as a benchmarking measure, and the control group is identical to all other items or subjects that you are examining, with the exception that it does not receive the treatment or the experimental manipulation that the treatment group receives. So like we mentioned before, I have a pretest. During pretest, I have a control group, I measure, and I have a treatment group, I measure. Then I do the test, so post-test, I measure the control group and the treatment group. Very important. Why do we need to have a control group? Because it creates the benchmark to measure the success or failure of my test. It will minimize the impact of dependent variable, and it highlights false positives, signaling whether an update is more effective than the original or not. And it's very important to take this into account because it removes the confirmation bias or the tendency to force the hypothesis into results. And believe me, I witnessed PhDs that are defended and they are in the experimental research methodology, and they were never discussing what is their control group or what is their let's say noise reduction measures that were done. So without doing control and without having a control group and a treatment group and a pre-test and a post-test, you cannot communicate or share any confidence regarding results, and your communication or your whole outcome are uncertain, and the range of error might be very high. So it's very important when we talk about control groups that we have an imagination. Let's take this example. This is a control group with subjects. So the subjects are human beings. Here I want to have an experiment. Will the student test score be affected by distracting sounds in the testing environment? So in this sense, I have a control group. I must have a randomized control groups, a group of people I selected that will not be exposed to the music. And I must have a group of subjects that are exposed to the music. First of all, I divide both groups. I have to let them take the test, and I measure the cognition before the intervention for the control group and for the treatment group. Then I introduce my treatment. For group A, for the treatment group it's the music, for the control group there's nothing, and then they have to take the test again or take a similar test again to measure the cognition, and then I can compare the cognition for the control group before and after, and then I can measure also the cognition for the treatment group before and after. So here comes the complexity. But let me help you with this graph. Here you can see I have always to start with a baseline. I have a baseline information, I have a pretest to make sure that I have the same time conditions, I have same physical conditions for the people. Then I have a random group selection and a treatment group. Actually, the random group selection must be done to create a treatment group and a control group. I select both groups together. I introduce the treatment, and then I do the post-test, and I can quantify the effect, the measurements, and the comparison empirically. So this is how it goes when we design an experiment. It's very important. And again, if your subjects are not human beings, it doesn't make a difference. You must have a pretest, and you must have a post-test, and you must have a controlled group, and you must have a treatment group. So it doesn't make a difference if the subjects are human beings or not. Now let's go further. What is control group design? How to do it? Well, the control group design offers an alternative solution to the attribution problem, and it is divided in 4 times. First of all, I have baseline information, like the pre-test information. Then I have the 2 groups that are randomly selected, one receiving the treatment and the other not. This is the random group selection. And then I can introduce the treatment, and finally I have the comparison between the 2 groups, and in this comparison I have it before the test and after test. This is the end of today's presentation. I hope the message is clear, and I hope that you all introduce the control group concept or the reduction of noise concept and memorize what we said. So let's go through the takeaway message and we terminate today's presentation. Well, in experimental research, there is very important principles. One of the very important principles is to select and define your variables through operationalization. You try to generate a hypothesis, and you have to establish what relationships might be between the phenomena. So you are seeking here cause-effect relationships when you're doing experimental research. So make sure to identify the subjects of your experiment and your sample size, and this has to be done through a randomized control approach, randomization in the sampling and the recruitment, and the control will be that you measure before and after, and that you have a control group and you have a treatment group. So plan and conduct the research, and you have to see how can you observe the phenomena in a controlled settings, and how can, as much as possible, invest time and effort to neutralize and control the setting and allow benchmarks through baseline and control group. This is the end of today's presentation. I invite you to have a look at the previous videos or the next videos that will show up. This presentation is part of a playlist on experimental research. By liking and subscribing to the channel, you encourage me to continue to develop further these videos. I hope this presentation is valuable. I hope you can control more the noise in your work. And today's presentation was about planning and controlling your research. Thank you very much for your attention, and good luck with your research.